Okay, correlation coefficient ni the same concept lah kamu belajar dalam apa? First year statistic regression. Okay, regression kamu ada apa? Pearson product moment correlation coefficient. Okay, kamu ada dia punya formula dia. Kita ada SXY. Kalau kamu ingat balik lah ya. Kita ada SXY square root your SXX and then your SYY. So it's the same thing. SXY is your covariance XY. Divide by square root SXX is your variance X. SYY is your variance for Y. So the same thing. Okay. So ini cuma this one in terms of kita punya random variable lah. Kamu ada X and Y. So now kita nak dapatkan dia punya covariance. Kita dah tahu formulanya apa. So covariance is just apa? EXY minus EX times EY. Okay. So if you want to find your correlation coefficient, so covariance XY is just sigma XY. Okay. Divide by square root variance X variance Y. Okay. Variance X sigma square kan? Variance Y sigma square juga. Okay. Square root. So that means you get sigma X, sigma Y. So that is your value, your formula for your correlation coefficient. Okay. Perkali korelasi. Okay, again, correlation coefficient pun, we have a single value, not a value in terms of your X and also your Y. Okay, so let's say, okay, ini saya direct je lah ya. So you want to find your covariance and correlation coefficient, cuma jalan kerja tu panjang sikit. Okay, so again, you have X between 0 and 1, Y between 0 and 1. So you need to find your covariance and correlation. So in procedure, nak dapatkan covariance dengan correlation tu, since you already have your bivariate density. So kalau covariance EXY minus EX minus EY. So you need both those values. Okay. So that means you need to find what is your marginal function first. Marginal for X, marginal for Y. Once you already get your marginal function, okay, use the formula. Formula for expected value of X square, and then expected value of Y, expected value of Y square. Okay. Because you need that one to find your variance. Yeah. Okay, that's mean the first step, find marginal function. So marginal function, so integrate with respect to Y, marginal for X. So solvekan dia punya integration dia. So we just have XY plus Y square over 2. Okay. So marginal for Y, so integrate with respect to X again. So selesaikan half plus Y. Okay, now kita nak dapatkan dulu apa dia punya variance dia. Okay, variance because you need to compute your correlation nanti. So EX, X times your density function. EX square, so X square times your density function. Okay, so now you find your variance ni. So variance, so EX square minus EX square kan. Okay, sebab kita guna konsep marginal. Okay, the same thing for Y. So dapatkan EY square and then find your variance. Okay, now you have to find your EXY. Okay, kita perlukan EXY. So EXY, kita boleh check lah sama ada dia independent atau tidak. So kalau dia bukan independent, EXY, so that's mean you need to integrate lah. So XY times your density function, X plus Y dy dx. Okay, solvekan. Okay. Once you get your EXY, compute dulu what is your covariance. Okay, tulis balik formula EXY minus EX, EY. Then substitute. Okay. Next, find your correlation coefficient. So the formula is sigma XY, which is your covariance. Divide by sigma X, sigma Y. Okay, sigma X, so that's mean square root variance of X. Variance X, kita dapat apa? This one. Variance Y pun sama value dia. Okay, so square root both. Then you get your correlation coefficient. Okay. Cuma step by step lah kamu dapatkan dia punya ini. Ini kalau let's say EX salah, EY salah, dia hampir semua salah lah. Okay, mungkin dari segi marginal function tu make sure kamu dapat marginal function yang betul. Okay, so you get EX. Sebab kita perlukan that one, EX square, then you want to compute what is your variance. So the same thing for variance Y. Lepas tu baru kita nak compute your covariance and also your correlation coefficient. Okay, so itu solution dah ada ya semua tu dalam tu. So just tengok balik lah. Okay. Okay, boleh follow ke setakat ni? Okay, so that one is your concept for, yeah, okay, sampai correlation coefficient kita ada concept for variance and then how you want to solve your correlation coefficient. Okay. So the next one, kita akan tengok 4.13 Kalau tak ada apa-apa soalan, saya proceed dulu. Tengok dia punya ni. Okay, so this one is your expected value for a linear function of random variable. Okay, linear function of random variable. Kalau sempat kita masuk sikit lah conditional expectation tu. Okay, again. So maksud a linear function of random variable, okay lah kita ada U is a linear function, maksudnya kita adalah AS1, AS2 and so on. Okay. So this one is just you want to find your properties for your expected value. So suppose that you have a function y, okay, a function of x1, x2, xn, okay, and then we have fx1, x2, xn is the joint probability function. So if u is a linear function, so that's mean if we have summation ai xi. Okay, kita ada summation ya. So that's mean your I is equals to 1 up to n. So we will have, kalau kita expand, A1 S1, A2 S2 plus AN XN. Okay, itu kita panggil sebagai a linear function. So now kita nak dapatkan dia punya expected value. Okay, expected value of a linear function. So if you have your S1, S2, Sn are random variable, so kalau nak dapatkan expected value, just simple je lah. So kamu akan ada expected value of Y, summation, AI, expected value of Xi. Okay, so maksudnya kat sini lah kita ada expected value of summation, AI, Xi. So kalau ikut balik dia punya properties tu, is the same thing lah. Kalau AI kamu adalah constant, so AI, expected value of Xi. Okay, so if you have your variance, so kalau kita nak compute variance, sebab ini multiple variable, okay, yang tadi kita ada variance x plus y saja, two variable. Okay, kalau kita ada variance y, variance summation summation ai si, you will have summation ai square variance xi, okay, plus 2 double summation AI, AJ, covariance, XI, XJ. So itu kalau kita ada multiple variable. Okay, multiple variable. So that's mean you will have variance Y, AI square, variance SI, and plus 2 AI, AJ, covariance XI, XJ. Okay. So again, kalau let's say if you have this one are independent, so you have covariance SI, SJ is equals to 0. So you just have this term je lah kalau dia adalah independent. Setiap variable tu independent. Okay. Okay. So ini the same thing. Okay, yang ni nanti cuba kamu proofkan. Okay, cuba cari reference textbook lah. Okay, reference from your internet ke apa ke. Okay, you can Google this one. So find how they prove variance y is equal this value. Okay, ini kamu punya exercise ni. Macam mana kamu nak proofkan? Okay. So you will have summation AI square variance SI plus 2 double summation AI AJ covariance SI AJ. Okay, kita akan generalizekan. Expand, lepas tu generalizekan dia punya formula dia. Okay, sebab kita ada I equals to 1 up to N panjang. Okay, so kita akan generalizekan formula dia. Okay, cuba tengok this one Cuba solvekan macam mana. Okay, let's say, okay, again, this one pun kamu dah tengok sebenarnya. Okay, kita dah prove mungkin dalam taburan pensampilan, sampling distribution during your first year. So suppose that S1, S2, Sn are independent random variable. Okay, each with mean P and variance P1 minus P. Okay, so keywords here, you have your independent random variable, and then you have your mean, and then you have your variance. Okay, mean and also variance. Okay, so that's mean. Okay, you have expected value of S1 is P, variance X1 pun, you will have P1 minus P. Okay. Okay, kalau kita dapatkan expected value of X2 is also P. Variance of X2 pun is also the same thing, P1 minus P. Okay, sebab dia adalah independent independent random variable, meaning P, variance dia P1 minus P. So let's say we define Y is equal to summation Si over N. So you need to find your expected value of Y. So expected value of summation Xi over N. So you have 1 over N, expected value of summation Xi. So expected value of summation Si, kita expand lah. So kita ada E X1 plus X2 up to plus Xn. Okay, setiap value tu kita follow balik dia punya properties of expected value. So you will have EX1 plus EX2 plus EXN. So this one, all this one. Okay. So semua ni kita ada nilainya adalah P. Okay, ES1 P, ES2 pun P, ini pun P. So that's mean you have NP over N, which is your expected value of Y is equals to P. Okay, macam kamu provekan dalam sampling distribution. Okay, kalau kita nak prove for variance, so variance pun the same thing. You go to the properties for variance. N is a constant value, so 1 over N square. Okay, so variance S1, variance S2, variance Sn. So variance S1 is just P1 minus P. Ini pun P1 minus P. So all together you have NP1 minus P. So cancel out kan ni dengan square ni. So you get this one. Okay, so it's the same thing as sampling distribution of a single proportion lah. Okay, so that is the properties dia lah. Properties, and then macam mana kita nak solve kan for linear random variable. Okay, so the same thing kalau mu ni. Ni pun simple je. Okay, kamu ada S1, S2, Sn independent random variable, each with mean mu, variance sigma square. Y is defined as summation Xi. Okay, so the same thing, expected value. So expected value of summation Xi. You will have X1 plus X2 plus Xn. Okay, split kan EX1 plus EX2 plus ESN. Okay, mu, mu. So you have and mu. Okay, variance pun the same thing. So variance Y. Sama je. Okay, so you have variance Y1, variance Y2, variance Yn. So all together N sigma square. Okay, so that is how we use the properties if we have a linear function. Okay, linear function of random variable. Okay, so itu basically that one dia punya still lagi properties dia. Okay. Ada apa-apa soalan ke? Okay, laju sangat saya ajar ni.
Saya nak tanya.
Aha.
Kalau macam tu untuk expected value dengan bar sentiasa N darab apa yang soalan bagi.
Okay, kamu susun dulu. Let's say katakan macam contohnya yang ni. Ya. Okay, kalau contohnya kat sini, sebab dia dah cakap X1, S2, Sn are independent random variable with mean P. Each with mean P and variance dia. So that means setiap value variable kamu tu, mean dengan variance dia sama. Okay, bila mean dengan variance dia sama, so sekarang kita ada a linear function which is summation Si over N. N is your constant je. Okay, kita boleh carry out lah. So sekarang kita dapatkan expected value of summation Si. So S1, S2, Sn. Okay, so guna balik properties dia. So kita dah tahu benda tadi tu adalah independent variable. So EX1 pun P, EX2 pun P. So kita ada N terms. Kita ada N variable lah. S1, S2 sampai N. So mesti P tu sebanyak-banyak. So sebanyak N, P. So NP divided by N. So that's why kita dapat balik P. So the same thing kan juga kat sini. Yang ni kita ada render taburan normal. Okay, cuma kat sini dia bagi Y equals to summation XI lah. Okay. So Y equals to summation SI. So variance summation SI. Summation satu level XI. Sorry. Okay, summation SI. So that's mean X1, X2, Sn. So split kan properties dia. Properties for variance. Variance X1. Okay. Plus variance X2. Sampailah kita ada variance Xn. So dia ada n term. So variance 1, sigma 1, sigma square. Sampailah sini pun sigma square. So berapa term semua ni? So kita ada n term. So that's why you get n sigma square.